Hello everybody. Welcome back to the Java Basics for Hadoop by Advancers. So what we have done till now is we have finished 1/4 of the Java syllabus for Hadoop, and let's quickly see what we have done. We had started with our basics of programming, what is an object, what's an instance, 4 pillars of OOPS. Let me do a word wrap so that it will come in the one screen. Then we saw our first example. By now you should be very comfortable with Eclipse, how to create a new project, how to create a package. Then we spoke about in our session 2 the entry point be the main method. We will talk about access modifiers, the 3 types of variables, difference between static non-static methods, non-static variables, then static non-static methods. We spoke about the constructors, the this keyword, the super keyword. Then we spoke about the data types and the various types of operators that we have. So in this session, we are going to focus on, let me go down and make a note of this. We will discuss with our flow controls. What are the 3 categories of flow controls? We have got something called as loops. Then we have got something called as selection statements. And then we have got something called as jump statements. So we will be discussing this because this is going to be used quite a lot in our actual MapReduce programming. After flow controls, we will talk about order of constructor calling. So that means in case if there is a multi-level constructor, how is the various constructors called, order of constructor calling. And then we will talk about call by reference, what is call by reference versus what is call by value. So let me make a note of this, call by value. So that's what is going to be our plan of action for today. So let's get started with the help of loops. Flow control typically would mean the way the program flow would happen. So when we talk about loops, the various loops that we are having in our Java programming language has been from what is available earlier in your C and your C++ programming, nothing new in that. So we have something called as a for loop, a while loop, and we have got a do while loop. A for loop is basically for iterating through a set of values. So let me go ahead and give you an example of what's a for loop. So let's go ahead and create a new class over here and let's call it as the for loop. Of course, it would have a public static void main and I would say finish. Okay, there we go. So let me close this. Let me delete whatever is there in main. And now what am I going to have here is I want something to be printed for X amount of time. Let's say I want to loop between 1 to 10 and I want to print out the values. So for loop is like the word suggests for. So you start with the for, and when you do a control space, it will give you a IntelliSense of whether you want to loop over a collection of elements. That is what is basically an array. Okay, you can iterate over something called as an collection. So collection is what we will do in generics as we go ahead. Okay, there we go. You can also have a for each loop which is going to iterate over an array. So this is what is called as an enhanced version of the for loop. Okay, so these are the various options we have. Let's talk about the very basic for loop which is going to iterate over something. Okay, so I would say the first part is what is called as a declaration part, wherein we declare the variable, decide from what point it's going to start with. It's going to start with 0, and then you can specify the condition to which it should go. So the condition that I wanted to be printed is 10, and then the increment part of it. The increment part of it can be empty, or the increment part of it can be, see over here right now the value of I is 0. So the increment part of it can be empty, or else I'll keep on incrementing it. So once it enters the condition, it will once it enters initialization, it will go inside this. It will look at the condition. If it is false, I less than 10. If it is true, it will pick over the iteration, and it will keep on happening till the time I is 10. So let me simply print out the value. So I'm going to say sysout of, I'm just going to say I over here so that it makes our life very easy. And I'm going to save this. And you know there are a couple of ways to run this. Directly click on this run, go down to the project, clean, and then go down to the run and say run, or you can say run as. Okay, in case if you want to give some values. I have got multiple options here, don't worry about it. Or else you can say right click and say run as a Java application. So I have run it as a Java application, and you will see over here that it will start with 1 with 0, because that's what my value is starting with. It will keep on iterating till the time it reaches 9. When it reaches 10, it becomes false and it will come out of it. So that is how a typical for loop would be. A for loop, purpose of a for loop is to typically go through a set of things what you have entered into your arguments. Okay, so we have already seen our configurations wherein I said that the value of args is to pass any values to your program. So you can go through your list of arguments and find out if you are expecting 2 things, then it should do that. If anything less than 2 is there, it should give you a message. Okay, so let's comment it for the time being. The way how you comment it is, you can have a multi-line comment as slash asterisk and an asterisk and a slash. So that is what is a multi-line comment. So now let's say I say if, I say control and space, there is a if statement. The condition over here is args is an array, dot length will give me the number of elements is less than 2. Okay, so if you expect minimum 2 elements to be there, and if it is less than 2, we can give a sysout, that means system.out.println, and tell the user that you have not entered both the values. Okay, just to give you a simple example of it when it will come. Else, let's write a simple sysout to say that you are all good. Sorry. Come on, my spellings is not correct, very silly. Let me go down and say sysout. Yeah, there we go. So I would say you are all good. You are all good. Okay, so that's how you'll have a simple example. So now let me say right click, run as a Java application, and it tells you have not entered both the values. Now if I say right click, run as, run configuration, I need to ensure that I'm there in the for loop. Yeah, I'm there in the right one. So I go down to my arguments. I'll say hi and let's say there. And I will say run. And then it says you're all good. So if you say 2 or greater than 2, then you're all good. Anything less than 2, you have not entered the value. So this is typically to give some validation checking in the command prompt to ensure if the values are being entered or not being entered. Okay, so that's perfect. So now let's move on. So this is a simple example of how you can use your for loop and a condition to check it up. The next type of a loop is a while loop, which is to loop till the time there is some value. So while is to iterate over a set of things. So I will simply say new class, and I'm going to say over here while loop, and I will say finish. Let me remove the values, remove the unnecessary comments. Okay, so now I could say over here if my let's take int a is equal to 10. Okay, and I will say I'll keep on looping it till the time I reach a condition. So while will be in a position to iterate over something or loop over something with an enumeration. So enumeration and is a part of a collection. You can use a while loop to iterate over an iterator. We will see both of these things as we go ahead. For the time being, we will use a simple while condition. So the condition over here is going to be a less than 10 again. Okay, and then I say sysout of a. So I'm having a simple loop which will go through a condition. The condition is something that would be the business logic that will be involved. And now if I say right click, run as, and run as a Java application. Okay, is I is 10. I is of course not less than 10, so it won't work. So let me go ahead and make I as 0. And then I give a condition and let me click on run. and this becomes an infinite loop because there is no increment over here. So you have to be very careful with this. I'll have to click on this, stop to terminate this, because this is an infinite loop. You have to be very, very, very careful with this infinite loop condition. So in a while loop, if you are blindly putting something, you will have to have the increment logic inside the loop. If you want it to be incremented, it should be done inside the loop. Now if I say a++, and then when I increment this, when I save this, see over here it has printed like what we have done earlier. So a is equal to 0 till a is equal to 9. So this is an example of a while loop which will loop through a set of values and give you some answer, folks. So in the for loop, you were looping through a set of values, and this is a while loop. So after the for loop and the while loop, we also have a loop called as do while loop. The only difference in this do while loop is that it will get executed at least once even if the condition is false. Okay, it will get executed at least once even if the condition is false. Because why? We first say a do, then we have a curly braces wherein we specify what you have to do, and then you check your condition. So these are the various loops that we have. Then we have got something called as selection statements. So selection statements are basically like if, or if you have got a if-else condition like what we saw right now in the example of args.length. And we also have got something called as switch, or this is what is also called as case. So let's see an example of a switch. So please note, switch can only take a byte, a short, sorry, this is a small typo, it's not a short, it's short, S-H-O-R-T, byte short, int, or byte short, int, or long as its parameters. That means, hey, just one sec, it'll take a byte short, int, or char, not long. I was wondering something is wrong there. So it can take a byte short, int, or char as its parameters. That means it can't take floating point values and it can't take long as its in its value, because the options would be simply too much. So let's go ahead and see an example of a switch test. So let me go ahead and create a new class, and let's call this as switch test. Let's make it as a convention as S capital, and I would say finish. So what am I going to do over here is I'm going to, let me delete the unnecessary to do statement which is not needed. I'm going to have a for loop, control space, iterate over an array, I is equal to 0, I less than 3. Okay, then I plus plus, and then I am going to say switch of I. Okay, I said control space, which came up. Then case of value, the value over here is going to be, let's say 1, or let's say 2 deliberately. Okay, you see break is there after every case. Okay, and after default also there is a break. So if break is not there, it will go into all the cases below the case and you will get some weird output. So break is mandatory. So let me write a sysout statement and tell you system.out.println of, let's say 2, because this value is 2. Then there is a break. Then I will say, sorry, case, not class, case 1 colon, and I'm going to say sysout of 1, and like the best practice, let me say break. And then if it doesn't match anything, of course I need a semicolon here. If it doesn't match anything, it will go down to the default. Okay, so now let me run this. Let me take up the options output window up a little bit, run as a Java application, and you'll see the output of 1 and 0. Oh, sorry, 1 and 2, because for 0 it has gone to the break. If you want to print out something, I could have printed out a value, okay, in break, so that you know that break is getting called. So when I run this, you see that it prints me in break. Now what would happen if the comments are not there? You will get some weird kind of output, but then it is systematic in that weirdness also. There is a sense. Okay, so once a case enters into any of the cases, it will simply print all the values below that case. So see what would happen when I run this. What does it first print? It prints me in break. That's for the 0th iteration. For the first iteration, it printed me 1, and then it again printed me in break. This is for the first iteration, and this is for the second iteration. So it's very important that when you have a break, you should have a a switch case. You should have a break statement. Otherwise, it is bound to give you unpredictable outputs, folks. Okay, so that's what we have in our selection statements. Then we will have jump statements. So the two jump statements that we have over here is what is called as break, like what we saw right now, and continue. Okay, so the break is used to, as we saw in the last example, exit a loop. So the three uses of break are to exit a loop. That's what we saw. Then it is also commonly used to exit a switch case. Okay, so since you are just learning this from the basics of Java point of view, I would stick to the two uses of break, but then please note there is also something called as labeled break, which is a little bit confusing and it is not needed to learn right now, but then you should also remember that label break is also present. It is there in complete reference. So once you get a good hands-on on the Java part of it, then you can go ahead and continue learning that. Again, the focus over here is to not to teach you Java, but teach you enough of Java so that you will be able to understand MapReduce code and work around with that. That is what is the intention over here. For learning Java, Java is a huge topic and it will take quite a bit of time. That's not the intention. The intention here is to prep you up in such a way that you understand the basics so that you'll be able to follow the MapReduce code and even do coding if needed. So that's why I put this as the third use. So the uses of break. What is the use of continue is, continue is used to exit the current iteration and continue with the next one. So you might be wondering what might be the use case where I have to say continue, because by default the value will be continued every time, right? So let's take an example. So there's nothing better than giving small examples which would make your concepts clear. So let me call this as continue test, and what I'm going to have over here in continue is going to be, I'm going to have a condition. Let's say I have got a for loop. Let me write the use case. I have got a for loop which is going to loop from 1 to 10, and I want to print odd numbers. I don't want even numbers, I want odd numbers. So first let's have a loop. Let me close the earlier output statement so that it will become easy for you. So first thing is we would need to have a loop. So I'm going to say for, I iterate over an array. The condition over here is going to be 10. Okay, I++. Then what I need over here is I want you to print the odd and the even numbers. So for that, the best use is via the modulus. So I'm going to say if, and I could say control space and the if statement will come. If my I mod 2, remainder of 2, is even, that means if it is equal 0, okay, then I will say continue. Else I will say print. So actually there's no need for else. Without that also it will work over here. So I'll say sysout of I. So what will happen over here is when it goes down to the 0th condition, okay, it will check if it is remainder is 0, yes. So when it hits the continue, everything after the continue is skipped for that current iteration. Okay, it is not skipped permanently, it is skipped only for that particular iteration, and then the value goes on. That is what is the use of your continue test. So let me simply run this. Of course, I want to run it as a Java application, and you'll see here that it'll print me the odd numbers. The even numbers are continued. So the main purpose of continue is to skip the current iteration and take the control onto the next iteration, folks. Perfect. So that was all about our flow controls. So again, very important, the various operators and flow controls. Let's talk about order of constructor calling. So as you have seen that the object class is the base class of all classes in Java, and all classes inherit that. So what would happen if there are multi-level constructors? So let me go ahead and give you an example of my constructor order of constructor calling. So let me create a class. And I'm going to put everything inside this, although there are multiple classes. That is just for the purpose of simplicity and for your understanding sake. So I'm going to create a class called as const order, that is constructor order. Okay, this is what is going to be the entry point. But before this, what I'm going to do is I'm going to create some other classes. So I'm going to create a class called as 1. Okay, so in the class 1, I am going to have, let me close my curly brace, there we go. In my class 1, I am going to have a method called as void met1, which is simply going to have a sysout of met1. Okay, and then in the same class, there is going to be a constructor. Constructor will have the same name as the class name. I am going to have a default constructor, and I will say sysout of, in double quotes, I would say this is 1. So that is what is my structure. Then I'm going to have class 2 extends 1. So you will have inheritance over here. So extends is a keyword for inheritance. In that, I'm going to have a constructor called as 2. Okay, and that constructor is also going to have a sysout of this is 2. That's it, nothing else. I think I'll keep this here so that it will become easy for us to understand. And let me close all of this output. At the time of output, I will increase the decrease the height of it. Then I'm going to have class 3, which extends 2. So you see over here, I have got multi-line constructors. Okay. Then in this also there is 3. That means it has also got a default constructor, which is also going to have a simple sysout statement that this is 3. Okay. So you have got 3 constructors, 3 classes, 1, 2, 3. The base class has got a method called as met1. So as per inheritance, you know that whenever you create instance of the subclass, the subclass instance can call the base class instance, right? So that is what is the concept of inheritance. But what is very important over here is, since this class is extending another class, every subclass in the first line have got an implicit constructor. That is what, implicit super keyword, not constructor, my apologies. It has got implicit super keyword, which calls a default constructor of the base class, and this process goes on till the java.lang.object class is created. And after that, in the way in which it was called, it will come the reverse way. So just to confirm that the base class constructors are already called, I am simply going to say 3a is equal to neo3. So a simple variable over here. Okay, I am creating an instance of the class called as 3, and when I run this, you will see that all the base class constructors are called in that particular order. See, this is 1, this is 2, this is 3. So the point to be noted over here is all subclass constructors have an implicit super in their first line, which calls the default constructor of the base class. This process goes on till the topmost class is loaded in memory. Okay, so this is what is the use of your implicit super keyword. So this is what is the meaning of the constructor calling. So imagine if the base class constructor was not called in the memory, that instance would not have been there in the memory. If the instance is not there in the memory, how will the subclass know that there is a method called as met1? And this process of order of constructor calling is very important, and this is the underlying base on which your overloading and your overriding technologies are based. Overloading means having a same method with different parameters, and overriding means a subclass overrides a method of the base class. So these concepts totally rely on this concept that whenever a subclass instance is called, it will implicitly call the constructor of the base class, and it will go in a reverse way till the topmost class is loaded in memory. So now to confirm that, let's go ahead and say my a dot met1, and I put a semicolon. So if our analysis is right, it should also print me met1 over here once I run this. So let me run this. Yes, you can see here all the constructors are called in the order in which it is created, and it will call met1 function also. So that's the concept of your order of constructor calling. Unfortunately, we don't have time right now to talk about the call by reference and call by value, but we will be doing that. So I'm just cutting it out from here. And when we start with our session 6, every session is of half an hour. Okay, so session 6, we will first talk about call by reference and call by value. Once we do that, we will talk about inner classes. This concept is also very important because a class within a class is what is called as inner class. Okay. So what did we do today, folks? We started with our session 5. We spoke about our flow controls. So the different flow controls that you have is loops. There is a for loop, while loop, do while loop. Then you have got selection statements, which is nothing but if else statements, and then you have got a switch statement. So switch works hand in hand with the case. So some people call it as case statements. Then you have got jump statements, which will allow the code to jump into a particular place. Either you can use the jump statements for a break, so that it will break the current flow, or else the jump can also be used for continue, which is used to force the control to go to the next iteration. Okay, so that's what we have seen till now. Then towards the end of it, the last example that we saw was order of constructor calling, which means that if there are multi-level constructors, all the constructors of the base class will be loaded in the order in which it is inherited till the topmost class, that is java.lang.object is created, and this ensures that all the variables and data members are loaded in memory before the subclass object can be loaded, friends. Okay. So that's it for this particular session. Hope you have enjoyed this session and looking forward to you in the next session. Thank you. This is Venkat signing off from session 5.